Hello everyone, welcome to my creative element. So I wanted to start by saying that I was really interested in geothermal energy because I've actually been to Iceland and I've experienced it for myself. I've seen the power plants and they do produce a lot of steam. They smell like sulfur and they're pretty cool. The hotels were always really nice. They were powered by geothermal energy and they were always really hot, sometimes too hot, although that might have been because we didn't know how to control the thermostat. We swam in the hot springs, which were heated by the geothermal energy, and those are really nice. Um, yeah. Anyways, I'll show you some clips of me explaining how the geothermal power plants work. Alright, so I found this really cool graphic of a dry steam power plant, which is the most commonly used power plant that harnesses the geothermal energy. So it all starts down here, which doesn't show, but there's a reservoir of water, and that water is heated by the magma, which was heated by the radioactive decay of the isotopes. And so that water is heated and it turns into steam, and it comes up these pipes, which then use this steam to rotate this turbine, which then produces power, which goes to, homes. Then the water cools back down here, and it goes back down into the reservoir, and it can just continue this process, generating clean, renewable energy. Here's another incredible geothermal energy production station. And this one is pretty much the same as the other one, except it kind of utilizes the property of these fluids being super pressurized. And so, because the fluids are super pressurized, when they come up to this low pressure container on the surface, they immediately turn into steam, which goes into the turbine, spins the turbine, and powers the generator. And then it works basically the same way as the other one, where the water cools and goes down back into the reservoir. Lastly, we have this binary cycle power plant, and to me this is the most interesting power plant. So instead of taking this super hot water and piping it through the whole system, we actually have lower temperature water. It's still pretty hot, but it's lower than the other power plants that's cycled through here. And that actually powers another fluid which has a lower boiling point than water, and so that actually turns into steam and powers the turbine, which powers the generator. And so I thought that was pretty cool because I can see this being used in places where you might not have a super hot spot underneath the ground, but you still want to use that geothermal energy, and this could be really useful there. I actually found this really cool diagram of the radiogenic heat, or the heat generated by those decaying isotopes in the Earth's crust. And we can see that places like Utah and Idaho could really benefit from geothermal energy because their crust is so hot. When it comes to us up in New York, I think we can still, it's a little hard to see here, but we're still in this yellow range, so I think we could definitely benefit from some of that lower temperature binary cycle power plants. In conclusion, I think we should replace Queensbury High School with a geothermal power plant to maximize clean energy efficiency in our local community. And that's about it. See ya.